Let's say one day I'm just sitting in my basement, and I'm not causing trouble for anybody. I'm literally just hanging out, having a good time, when all of a sudden, 6 raccoons invade, and it is very clear that they want to take over. Luckily, I just happen to have baked a dozen cupcakes, which hopefully I can use to calm down these ravenous beasts. Ever the physicist, I start to wonder, what if I just treat cupcakes and raccoons as if they are units of mathematical measurement, almost like a meter in a second, like, okay, 12 cupcakes and 6 raccoons. Well, what can I do with that? I can't really add cupcakes and raccoons together. 12 cupcakes, 6 raccoons equals 18, rack cakes? Cupcoons? It doesn't make any sense. The same goes with subtraction. Now, this is going to be helpful to keep in mind when you start doing stuff with actual units, like meters and seconds. If I've got 4 meters and 2 seconds, I can't really add them together to get 6 anything. So when you are adding and subtracting, your units must be identical. Multiplication and division are a little bit different, though. I could divide all 12 cupcakes by these 6 raccoons, and I end up with 2 cupcakes per raccoon. Notice how raccoons is in the denominator of the calculation, and raccoons, the unit, is in the denominator of the final product. So when you're multiplying and dividing, you can basically treat units as if they are variables. And this is actually something you've been doing all along. Take a square, for example. If you know that each side is 3 meters, you can simply find the area of the square. You learned, probably in elementary school, that the area of a square is just base times height, or side times side, or side squared. It's easy to deal just directly with the number, that's 9. But now take a look at it in terms of the units themselves. You've got meters and meters. So treating the units as if they're variables, let's just use the variable x. I know x times x is x squared. Well, meters times meters is meters squared. So this is a calculation and result that you're probably comfortable with and used to, but hadn't actually talked a whole lot about where these units come from. One of the first topics we'll talk about in physics is displacement, velocity, and acceleration. So keep all of this in mind as we start down that path. So for example, let's say I've got 4 meters and 2 seconds. If I try to add them together, it simply doesn't work. So if I've been completing some sort of calculation and I've kept track of my units and I find myself at this spot, I can already tell I've done something wrong and I need to go back and look at what I've done. However, if I try to divide them, that right there is not a problem at all. And I end up in units of meters per second, so I know I'm dealing with some sort of velocity. Keeping track of units can be one of the most powerful tools you can use to get ahead in physics. So always keep this in the back of your head as you go through these physics problems. No rat cakes, no cupcoons. Cupcakes per raccoon, totally fine.